All right, so a couple key vocabulary words here for this next section. This is our last method for solving quadratics, known as the quadratic formula. So this is section 5.3.1 study, the quadratic formula. So the discriminant is part of our formula, and it's known as the number under the radical sign in the quadratic formula. It is given by this expression. B squared minus 4AC. Now, an imaginary number. This came up on one of your problems from the homework worksheet, where we had the square root of -1 as part of our answer. And so the imaginary number is the square root of a negative number the imaginary I is defined as the square root of -1. So square root of -1 is equal to 1. And so you can use I equal to the square root of -1 to find the square root of any negative number. The quadratic formula. This is the formula used to solve quadratic equations. The solutions to ax squared plus bx plus c are given by this formula. X equals -b plus or minus square root b squared minus 4ac all over 2a. They make you sing this in some middle schools when they teach you the quadratic early. So I just want to let you know that you're welcome. I'm not going to make you sing it. So the solutions to a quadratic can be found by this formula every time. So if factoring doesn't work, if completing the square doesn't work, we can use this formula. Okay? So let's take a peek down here. The main idea. The quadratic formula can be used to solve any quadratic equation in this form where a is not equal to 0. So if a were to be equal to 0, can you see how the 0x squared, it would just make it a linear equation. It would no longer be a quadratic, so a cannot be equal to 0, or we can't use this formula, okay? All right, here comes the actual formula. X equals -b plus or minus b squared minus 4ac all over 2a. And now, let's take a little peek at this. There can be no term whose degree is higher than 2. Again, it needs to be an x squared equation for this to work. So your degree can be no higher than 2. The coefficient of the x squared term cannot be 0. Again, this cannot be 0 or it's not a quadratic. The right-hand side of the equation must equal 0 in order for us to calculate and solve using the formula. So just like completing the square, we want it equal to 0 before we start. Let's complete the steps to solve this one. All right, step 1, identify the values of a, b, and c. So if I write directly above this, ax squared plus bx plus c, I can then easily see that my a term is going to be right there. My b term is right here. And my c term, or my constant, is at the end. So my a is -3, my b is +5, and my c is +6. The signs matter. Substitute those values into this formula, and then we begin to simplify. So here I go. X equals -5 plus or minus 5 squared minus 4 times a times c, all over 2 times a. So 2 times -3. Now we simplify. Opposite of b, 25. Negative times a negative is a positive. Positive times a positive. This is going to be a plus. This sign in the middle of the discriminant is the most commonly missed section, so please be careful with this sign. 4 times 3 is 12. 12 times 6 is 72. And this is all over -6. Now we need to keep going here on this little radical. So 25 plus 72 gives us 97. So I've got -5 plus or minus √97 over -6. So when they want us again to split this into two answers, my first answer is -5 plus √97 over -6, or -5 minus √97 over -6. Now I want to show you one more way to write this answer that's also acceptable, is if this -6 separates out to each part. So -5 divided by -6 would be +5/6 plus √97 over -6. Notice how I split it apart. And then finally, or +5/6, because negative divided by negative makes positive, minus √97 over -6. So here are my two answers. So it can be written as an entire fraction over the -6, or it can be split apart into the two like this. The right-hand side of the equation, if the right-hand side of the equation does not equal 0, then you need to subtract the number or expression on the right-hand side from both sides of the equation to get it ready. So take a look at this next one. See how it's not equal to 0 yet? So I'm going to minus the 2 from both sides, giving me 2x squared plus 3x plus 3 equal to 0. And in this case, this has a 2x on the wrong side, so I'm going to subtract the 2x from both sides, and it leaves me -x squared plus 2x plus 3 equal to 0. So notice that if it's not equal to 0 yet, we have to do something before we get it ready. Then we can get a, b, c, and then we can use the formula. So now complete the full steps and then write the roots in simplified form. This is going to move to the next page. Let's go practice it again. All right, so again, getting a, b, and c. A in this case is an invisible 1. B is a -2, and c is a -1. We're going to plug these into the formula and then simplify. Opposite of -2, -2 squared minus 4 times 1 times -1, all over 2 times 1. So the front simplifies down to a +2. 4, so -4 times -1 is going to be +4. and that gives me 2 plus or minus root 8 over 2. Now, simplify the square root or radical. Remember how we've already had lessons on how to break up this 8. 8 could be looked at as the root 4 times root 2, or plus or minus 2 root 2. This 8 breaks up into a simplified radical of 2 root 2. So now when I go place this back in the formula, 2 plus or minus 2 root 2 over 2, or 2 over 2 plus or minus 2 root 2 over 2. Notice how I split the denominator individually with each part. Now you'll notice that that 2 can be simplified out. Final answer here is x equals 1 plus or minus root 2. These 2's became a 1, and these 2's simplified to become an invisible 1. What are my two answers? X equals 1 plus root 2 and x equals 1 minus root 2, my two final simplified answers. All right. So you read, the square root of a negative number is not a real number. The square root of a negative number is not a real number. You can't take the square root of a negative. So when you use the quadratic formula, you sometimes get a negative value in the square root. A negative value in the square root. Some quadratic equations do not have any real roots or any real solutions. They only have imaginary. What is the discriminant? The discriminant is the value under the radical sign. What is the formula for the discriminant or this equation? So remember, the b squared minus 4ac, that's the part under the radical in the formula, so that's my discriminant formula. So if we get a positive discriminant, or underneath the square root is positive, then the equation has two real roots or two real solutions. If we get a 0, the square root of 0 for your discriminant, then the equation has one real solution or one real root. And then what if there's a negative under that square root? Then the equation has no or 0 real solutions. It has imaginary solutions instead, with that little letter I. So let's do this final practice on just the discriminant. So before we can calculate the discriminant, you have to get me A, B, and C on each of these. So A equals 5, B equals 4, C equals negative 3. Now that I have this, I can plug into the discriminant. So B squared minus 4AC is going to be 4 squared minus 4 times 5 times negative 3. And so this gives me 16. Negative times negative is going to make this positive. 20 times 3 is 60. And so 16 plus 60 is 76. Since the discriminant is a positive 76, the equation has two real roots. It means that the graph crosses the x-axis in two places. Two roots, two solutions, two zeros. Let's do the next one. A equals 9, B equals 6, C equals 1. And we go do the discriminant. 6 squared minus 4 times 9 times 1, 36 minus 36. And that equals 0. So since the discriminant equals 0, the equation has one real root. The graph only touches the axis in one place. And so your vertex would essentially be right there on the axis. Finally, last but not least, A equals 1, b equals 2, and c equals 7. b squared minus 4ac is 2 squared minus 4 times 1 times 7. 4 minus 28 is a negative 24. Since the discriminant is a negative 24, it has no real roots or 0 real roots, and the graph never touches the x-axis. So picture a graph that's kind of like hovering above the x-axis. It never touches the x-axis. And that's your intro to the formula.